we will start our problem with a square with the area of 180 squared units. Then we're going to use the bottom side of the square to construct a small semicircle on the right, in such a way so that the diameter of the semicircle will be located on the same line as the bottom of the square, as you can see on the sketch. Now we're going to connect the top right corner of the square with the bottom right corner of the semicircle. And let's say that the bottom segment of this newly formed line has the length of 8. The question is, can we somehow calculate the area of this semicircle? This awesome problem was sent to me by my subscriber, Lumi. She's actually a 10th grader from Finland, and she says that this problem was from the math competition in her country. So thank you, Lumi, for this wonderful suggestion. And if you guys want to try it out for yourself, you can pause the video right now and then come back and check my solution. Alright, so let's solve this one together. So first, as always, I'm going to label all the vertices of our square as A, B, C, and D, and I'm going to label 2 points of our given segment as E and F. Now first, I'm going to start by connecting the points B and F, and I'm also going to temporarily label the center of our semicircle as O. Now let's use one of my favorite circular theorems, the Inscribed Angle Theorem. This theorem states that if we have a circle and the inscribed angle inside the circle, then this angle is half the measure of the central angle that intercepts the same arc. And I'm going to label the sketch on the right the same as sketch on the left, so you can follow along more easily. Now, if you take a look at our sketch on the left, at our semicircle, you can see that the angle at the point O must be a 180-degree angle, since this is a semicircle. This means that the angle at the point F is our inscribed angle, and it must be the half of 180 degrees, so this must be a 90-degree angle. Why is this important for us? You're going to see later. Now let's clear our image and let's label the segment CF of our line EC as X. Now let's have a look at the triangle BEC. And the angle at the point B of this triangle must be the right angle. This is due to the fact that the angle at the point B is also the angle of the square. Now, this of course means that the triangle BEC is a right-angled triangle, and we're going to use a really interesting theorem which is called the Euclid's Cathetus theorem. Or in some other literatures you can also find it as a leg theorem. So, for this theorem we need a right-angled triangle, and let's label its sides as A, B, and C. Now, if we pull the height of this triangle, this height will divide the hypotenuse into 2 segments with the length of P and Q. Now, the Euclid's Cathetus theorem states that in any right triangle, the square of a leg, or cathetus if you like, equals the product of the hypotenuse and the projection of that leg into the hypotenuse. So, from our sketch, A squared equals the product of the hypotenuse and the segment P, and the side B squared equals the product of the hypotenuse C and the segment Q. Now this is really important for us, because now again I'm going to label the sketch on the right the same as the sketch on the left. And here you can clearly see that the side BC of our triangle equals to the product of the hypotenuse EC and the segment FC. And we're going to use this formula. Now I'm just going to substitute the values from our sketch and get the following. But what is actually BC squared? Well, if you take a look at our sketch, the BC is actually the side of our square with the area of 180. And since the area equals side squared, this means that BC squared is nothing but 180, which is something that we already know. Now, if we work through this equation and we put all our terms on the left side, we're going to be left with this really nice quadratic equation. Now, of course, you can solve this in multiple ways, and I usually solve it by using a quadratic formula, but in this video I'm going to mix things up and I'm going to use the method of splitting the middle term. So we're just going to take a look at this middle term of 8x. And now, in order to use this method, you will have to think in this way. Which two numbers that we add will get us to plus 8, and if we multiply those two numbers, we will get minus 180. So the question is, which two numbers satisfy those terms? Well, you can first notice that the product of those two numbers is a negative number. So this means that one of those numbers, A or B, must be a negative number and the other one must be positive. So this simplifies our search. And the only two numbers that match those two terms are plus 18 and minus 10. So we're just going to split our middle term of 8x into terms of 18x and minus 10x. Alright, so now we're going to work through this. First, we're going to isolate the common factor of first two terms and the common factor for the second two terms. If we do this, we will get the following. Now we can again isolate the common factor for our newly formed two terms, which is x plus 18, and we will get the following. Now, from this, you can clearly see that we have two possible solutions. The first one is that x plus 18 equals 0, and the second one is that x minus 10 equals 0. From the first equation, we will get that x is minus 18, and from the second, that x equals 10. Of course, x represents the length of the segment CF, so it really makes no sense for it to be a negative number. So the only possible solution for x is 10. Alright, so now let's clear this up a little bit and let's stay focused on our right angle triangle BEC. We can use the Pythagorean theorem on this triangle in order to find the leg BE. So BE squared equals to the hypotenuse CE squared minus the leg BC squared. And we're just going to substitute our values from the sketch. You can see that CE is nothing but the sum of the segments with the length of 10 and 8. And remember what BC squared is. Since BC is the side of our square, the BC squared is nothing but the area of the square, so this is 180. Now we're just going to work through this a little bit and simplify and finally get that BE squared equals 144, which means that BE must have the length of 12. But why is this important? Because, remember, we're looking for the area of our red semicircle, and BE represents the diameter of this semicircle, and we can label it as 2r. So 2r equals 12, which means that the radius of our red semicircle must be 6. Alright, so now it's pretty easy to find the area of this semicircle, as the area equals to 1/2 of the area of the entire circle of pi r squared. So now we're just going to substitute the value of r and get the following. From here, we can simplify this and finally get that the area of our red semicircle equals 18 pi, and this is our solution. So I really hope you guys enjoyed this problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this in the future. And if you found another way to solve this problem, write it down in the comment section. And as always, until next time, see you guys and take care.